Our next problem is an application of quadratic functions. We have a deli owner, and he has found that his revenue from producing X pounds of veggie cream cheese is given by the formula R of X equals negative X squared plus 40X. So we're going to give that a color. We're going to do that in orange. And the cost is given by another function, C of X is equal to 8X plus 192. Now notice that this is a linear function in blue, but the orange one is a quadratic because it has the squared. And then we'll delete. Graph both functions and answers the questions below. So let's go ahead and graph both of these functions. I'm going to pull up my Desmos and graph both of these functions. So as I go to type in my new functions, I've got some old functions here. To get rid of them, you just click the X. And you might need to rescale the graph, but we can mess with that later. So I'm going to type in y, instead of R of X, I'm going to type y equals. I'm going to use this little keypad down here, or you could use your keyboard. Either way will work. So I'm going to type y equals negative x squared and plus 40x. And that's going to be my revenue. Now this is a parabola, but you can't see very much of it so we're definitely going to need to change our scaling here. And for the C of X, I'm going to type y equals 8x plus 192. Okay, so I'm going to move that down, and I still can't see very much. You could use the plus button and the minus button here to kind of back out a little bit so you can see more, but still, when you finally get to see the whole picture, it's still not that great. I can't see what's going on in here because the parabola is so skinny and tall. So I'm going to click on this wrench, and in the wrench I'm going to manipulate my X and Y axes. The X axis doesn't need to be very large. Let's go from negative 100, and I'm just going to type negative 100 using my keyboard, to positive 100. And I can see a lot of the graph now. For my y-axis, I can see, let's see it a little bit higher. So let's make this the y-axis something like negative 50 to 500. And so I can see that much better now. Okay, now if you have a roller on your mouse, you can also roll in and roll out to manipulate what you can see as well. So that's kind of a nice feature as well. If you ever need to turn off a graph, you can click the graph off or click the graph on, and that's pretty cool. So let's go back to our paper. And we could draw a little sketch here if you want. My orange function kind of comes up like this, and this is really, really rough. And my blue function kind of does something like this. Okay, so the first question is find the minimum break-even point. Well, the break-even point would be where the revenue equals the cost. Where is the lowest point at which my revenue equals my cost? Well, on my graph, I'm looking for this point right here. That is where the blue line equals the orange line. Now, notice it happens twice. So we have two break-even points where the revenue equals the cost of producing the veggie cream cheese. We want the minimum one, which was the one that was closer to the x-axis. So I'm going to come over to my graph, and to find that value, all I got to do is click right around where I think that point is going to be, and the answer pops up. That intersection just pops right up for me, 8,256. So I'm going to come over here, and I have this point being 8,256. So what does that mean? The deli owner must sell at least 8, which is the X pounds of cream cheese, to break even. What does the 256 mean? Well, the 256 means if I have 8 pounds of cream cheese, the revenue is going to equal the cost, which is going to equal $256, which both costs the deli owner to make the 8 pounds of cream cheese. It also is how much he makes from the 8 pounds of cream cheese. So that's the break-even point. The next question says find the maximum revenue. Now revenue is orange, right? So I'm looking for the highest point. So I'm looking for this point over here. So I go back to my Desmos calculator and I just click on the highest point right here, and that turns out to be 20,400. So let's interpret that. The maximum revenue, that's R of X, right? So X is the cream cheese, the R of X is the 400, right? So the maximum revenue is $400 when the deli owner sells 20 pounds of cream cheese. So that's our maximum revenue. Next, we want to find the maximum profit. Now remember, profit is equal to revenue minus cost. So I actually have to find a third function, P of X. I'm going to take R of X, which is the orange, negative X squared plus 40X, and I'm going to subtract the C of X. And the C of X is that 8X plus 192. So when I distribute this, I have negative X squared plus 40 minus 40X, minus 8X minus, because I'm distributing the negative, 192. I can combine like terms and get negative X squared. The 40X minus 8X, that's positive 32X minus 192. So what I'm going to do now is I'm actually going to type that in the calculator so I can find the maximum profit. Now that's a purple function. It's a totally different function than the orange and the blue. It's kind of like a combination of the orange and the blue. So I'm going to come back to Desmos and I'm going to type in my new function. Notice I changed our graph colors to orange and blue. I did that with the settings button right here, and I just changed their colors just so it matched the colors that we chose on our paper. I can actually just turn off those two graphs because we don't need them at this moment. We're typing in a new function, P of X. So again, instead of P of X, I'm just typing Y equals, and you can use either your keyboard or you can use this little function keyboard as well. So we have negative X squared plus 32X minus 192. And that's what it looks like down there. If you want to see all three of them at the same time, you can have those other ones turned on. Let's make this one purple to match our other functions. Okay, so notice that our graph is much smaller than the other because we're only talking about profit and we're not talking about revenue or how much it's going to cost. So I'm going to turn those two off, and you can just scroll up here and use maybe the zoom in key, which is a plus, just so you can see it a little bit better. I know we're looking for the maximum, so when we're looking for the maximum, you're just going to click up here near the vertex, and the program will automatically find 16, 64. So we're going to go ahead and take that back to our paper. So I have the graph that looks like this, and this high point is 16, 64. Now I know these aren't great graphs, but I'm just trying to give you a visual because I can't put the Desmos graph in here. So what does this mean? What is the maximum profit? Remember, we have X is cream cheese, and then now we have P of X being the profit for the Y values. So the profit is actually $64 when the deli owner sells 16 pounds of cream cheese. That's going to give him the most amount of profit. Now that's different than the most amount of revenue because the revenue we had 20 pounds was going to get us the most amount of money coming in, but it's also going to cost us more. So the profit takes into consideration both revenue and cost and gets you just what you're going to pocket at the end of the day, which in this case would be best if you sold 16 pounds of cream cheese.